Welcome to section number 1, and in this section let's talk about differentiation of explicit functions. Now here I've started this by defining what are explicit functions. Now I've said that explicit functions, these are functions where one variable is expressed in terms of another variable. So let's take a look at an example. Assuming here we have our function y, and then this y is equal to x. So in this case here, you can see that we have our function y being expressed in terms of a variable x. And then also we can have y equal to x squared, something like that. It could even be x cubed. And then so those are some of the examples of explicit functions. Now let's take a look at how we can differentiate explicit functions. Now, before we get to differentiating explicit functions, we are going to use a rule, and this rule is called power rule. Alright, then, so what does power rule state? We have power rule here, and then it says that you drop the power of a, now in this case it is going to be the power of a variable, and then to get a new power, you subtract 1 from the previous power of that variable. This is what I'm talking about. Assuming you have our function, which is y, equal to x squared, something like that. And then before we begin differentiating, let's take note of this. The derivative function, or the function that we get after differentiating, it is called the derivative function. And then that function, it is either denoted by y prime, if at all you had your function as y, or it is denoted as the y, the x. And then this means that you're differentiating a function y with respect to x, whereby x is a variable of this function y. And then we have our y, which is an explicit function being expressed in terms of a variable x. And then so you say that dy dx is equal to, now here we are going to apply power rule. And then how do you apply power rule? We say that you drop the power, and then in this case our power, it is a 2. We have an x raised to a 2, and then so it means that we drop the power, which is 2, and then we keep the variable, which is x. Then to get the new power of x, we are going to get the previous power, which is a 2, and then we subtract a 1 from that 2. Then so it will give us 2 x raised to the power of 2 minus 1, which is a 1. So here it is going to be 2x. And then you happen to note that our derivative function, or when you differentiate y equal to x squared, it will give you the derivative function y dx being equal to 2x. And then by so doing, you've finished differentiating our explicit function. We've finished differentiating our explicit function. And so let's take a look at another example. So so assuming that we have also another function, and then that function, it is going to be y. Assuming we have another function y equal to, in this case we can have 3 x squared, something like that. And then so how do we go about this? How do we differentiate this? We follow the same procedure like in the first example. Our derivative function, or dy dx, it is going to equal to, now in this case you happen to note that 3, it is a constant. We have a constant here, or an integer 3 multiplying x squared. And then so it means that for this one here, we can just write 3, and then when we get to the very variable, because we are differentiating our function y with respect to x, so for that we can drop the power. So you note that when on dropping this power, it is going to be multiplying our integer, which is already there, or a constant, that is 3. And then after dropping that, we remain with x to power 2 minus 1. This is going to give us 3 times 2. It will give us a 6. Then x raised to a power of 1, which is the same as 6x. So we can say here that it is going to be y prime equal to, you're going to have y prime equal to 6x. Then if I say y prime, it is the same as dy dx. So here it can also be dy dx equal to y prime, which is equal to 6x. And then by so doing, we finish differentiating our explicit function. Aside here, let me leave some trial questions. You can comment if at all any of them has failed to come out, or if at all you want clarity about your answer. Then so let's have the first one as y, and have y equal to x. Yeah, let's leave it at that. So differentiate y equal to x, then number 2, and have our function like f of x equal to square root of x. Yeah, so then you also try to differentiate that. And then number 3, and have our function t equal to 1 out of the square root of x. Yeah, something like that also. Then at number 4, we can have our function, which is y equal to the cube root. This is cube root. Let me make it clear. It is y equal to the cube root of x. Yeah, so then let me add the last number here as our number 5 is going to be, let's have y, our function y equal to 4x cubed plus 3x, like that. Yeah, so you try out those numbers and